Dear students, welcome back to our chemistry class. By using reference electrodes, we have seen we can calculate the electrode potential of zinc as well as the copper. Like this, we can calculate the electrode potential of almost each and every elements by using the reference electrodes. And we are using, what sort of reference electrode we are using? We are using standard hydrogen electrode. Okay. Now we have to study another important term, that is electrochemical series. Electrochemical series, it is the arrangement of various elements in the increasing order of the electrode potential or in the increasing order of the reduction potential. All the elements can be arranged in their increasing order of the reduction potential or electrode potential, and that particular arrangement is known as what? It is known as the electrochemical series. A table can be made in which in the top the element which is having lowest reduction potential can be made. Generally lithium will be coming at the top. And arrangement, it goes like this way. Negative value, all those elements which are having low reduction potential will be, or which are acting as the anode, will be having negative value for their electrode potential, and in the center you will be having hydrogen in which it is arbitrarily fixed as 0, and below that you will be having silver, copper, like this way. And in the last, who will be the last member in the case of table? Fluorine, the element fluorine will be the last member in that particular series. So while we are moving up, the reducing property of the metals increases, or reducing property of the elements increases, or while we are coming down, the oxidizing, they will be acting as good oxidizing agents. If you are moving up, they will be acting as good reducing agents. If you are coming down, they will be acting as good oxidizing agents. Oxidizing agent. If you are going up, those elements, so lithium will be a good reducing agent, and here you will be having zinc, here there will be having sodium, potassium, and this particular table. So that is a explanation of electrochemical series. It is the arrangement of different elements in the increasing order of their reduction potential or electrode potential. Okay, hope you got it. Now we are going to see what are the advantages, or what are the how this electrochemical series can be used. Okay, shall we see? The first and important application is, it is used to find out the standard EMF. The standard EMF of the cell. You know, EMF or E cell is equal to E cathode minus E anode, isn't it? Everything under standard condition. So for example, shall we find out the E cell of Daniell cell? Daniell cell, the cathode is copper, as well as the anode will be having what? Zinc electrode. Okay, shall we calculate E0 cell, the value of cathode? What about the value of cathode? Value of cathode in the case of copper electrode, we have seen it is 0.34. What about the anode? Minus. It is having, what about the value of anode? Definitely it will be having a minus value, is 0.076 volt. So the Daniell cell's EMF is equal to 0.34 plus 0.76, it is 1.10. Okay, so this is the volt. So Daniell cell, the EMF of Daniell cell is 1.10 volt. So the first application of electrochemical series to find out the EMF of the cell under standard conditions. Okay, you got it. The second application, it helps to find out the reactivity of the metals. Those elements which are at the top will be acting as good metals, because what is the property of metals? That is the ability to lose electrons. If a metal is having great ability to lose electron, it will be a good metal. So those elements which are at the top of the list, that is lithium, sodium, potassium, etc., zinc, they will be acting as, they will be highly reactive. And this particular chart, that particular chart or table helps us to what? It helps us to compare the reactivity of metals. Now, which is more reactive, zinc or copper? Yes, zinc is more reactive. Why? Because the electrode potential of zinc is minus 0.76, as well as in the case of copper it is 0.34, positive value. So zinc is more reactive than copper. Which is more reactive, lithium or zinc? Lithium is more reactive. Why? Because the place of lithium is at the top, it is over the copper in the case of electrochemical series. So it helps us to find out the reactivity of metals. Shall we move to the third property? Okay, third application is that which metals displace this electrochemical series is a wonderful way in which you could find out which metals, which all the metals which could displace hydrogen from an acid. That is very useful thing, isn't it? Copper cannot displace hydrogen, whereas zinc displaces hydrogen from an acid. Lithium displaces hydrogen, sodium displaces, potassium displaces, copper, silver cannot displace hydrogen. How could we say? Because the place of copper as well as silver is below hydrogen. Hydrogen in the middle, which is having zero electrode potential, and copper as well as silver, they are placed below the hydrogen. So they cannot displace hydrogen from the acid. But in the case of zinc, sodium, potassium, lithium, they are placed above hydrogen. They are placed above hydrogen in the electrochemical series, so they can displace hydrogen from acid. So this helps us to find out which metals can displace hydrogen from an acid. Got it? Shall we see the fourth application of the electrochemical series? It helps you to predict the feasibility of an electrochemical cell, whether the cell would function or not. Feasibility of a cell. ഒരു സെല്ല് ഫങ്ഷൻ ആവുമോ, ഫങ്ഷൻ ചെയ്യുമോ ഇല്ലേ? നമ്മൾ ഒരു ആനോഡ് കാഥോഡ് എല്ലാം ഡിപ്പ് ചെയ്തു, കാഥോഡ് ആനോഡ് എല്ലാം ഡിപ്പ് ചെയ്ത് ആ സെല്ല് ഫങ്ഷൻ ആവുമോ ഇല്ലെന്ന് ചെക്ക് ചെയ്യണ്ടേ? എങ്ങനെ ചെക്ക് ചെയ്യാം? ഇവിടെ നമ്മൾ യു ആർ കാൽക്കുലേറ്റിംഗ് E0 cell EMF. If the E0 cell is having positive value, if you are having positive value, we are getting values from the table, we are substituting in our equation, we are getting the value, final value. If it is having positive value, it will be what? That particular cell will function. അങ്ങനെ ഒരു അവസ്ഥയിലാണെങ്കിൽ എന്ത് ചെയ്യുന്നു? സെല്ല് ഫങ്ഷൻ ചെയ്യുന്നു. കാരണം സെൽ E0 വാല്യൂ ഈ കാഥോഡ് മൈനസ് ഈ ആനോഡ് ആ ഇക്വേഷനിൽ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്ത് കഴിഞ്ഞാൽ, if you are getting a positive value, that shows what the cell will function. We have seen in the case of Daniel's cell, what about the E cell? is having 1.1. So this particular cell is having a positive value. So Daniel's cell will function if anode is zinc and if the cathode is copper. Okay, so that is the and fifth important application is that it helps us to predict. It helps us to predict the products of the electrolysis. If you are doing a process, electrolytic process, the values from the electrochemical series will give you an understanding about the product. What are the products you are going to obtain after a particular process? So these are the important applications of electrochemical series, which you have to remember, because question will be asked from that particular point. So these are the application. So in this particular section, we have seen electrode potential how we are calculating the standard, which is standard electrode potential. That is the electrode potential which is kept at the standard condition is known as the standard electrode potential. What are the standard condition? 298 Kelvin or 25 degrees Celsius, 1 atmosphere pressure, as well as 1 molar solution. The electrolyte should be 1 molar. And not only that, we have seen the reference electrode, the standard hydrogen electrode. There are a lot of reference electrode, but we are using standard hydrogen electrode. That is our reference electrode. And finally, we have seen how we are calculating, how we are finding out the values of different elements by using standard hydrogen electrode. This standard hydrogen electrode is a wonderful electrode, which is the electrode potential is arbitrarily fixed as what? It is arbitrarily fixed as 0, isn't it? It has been fixed as 0. So by combining with different elements or different electrodes, you could find out the electrode potential of each and every metals, isn't it? Or each and every elements, isn't it? So that is the case. So you are having what you could find out. SHE can act as anode as well as the cathode. Now we are having a table. What is the table? Electrochemical series. Electrochemical series is nothing. It is just a table or chart in which we are arranging different elements in their increasing order of electrode potential. Electrode potential here means electrode reduction potential. So those elements in the chart, above the chart, will be having lower reduction potential, and those elements below the chart will be having higher reduction potential. Those elements which are on the top will be having those elements in the top will be having negative value for their reduction potential, and those elements at the bottom will be having positive values. In between you are having what? In between you are having hydrogen. Hydrogen is placed because the value of hydrogen is 0. Negative value increases. You are having 0, and the positive value is increasing. Finally you are having what? Finally who would be the last member? Who would be the last member in that particular table? Yes, fluorine would be the last member in that particular table, and fluorine can be considered as what? It is a good oxidizing agent. Fluorine is a good oxidizing agent. Okay, so these are the things, and it can be used, and there are different application. We have also seen what different application of electrochemical series. Okay.